So, hi, hi guys. So we welcome to the second online event of Design by Data. We start with a little bit in delay because we have some technical issue. But anyway, we are going to start right now. This is the second online event, and tonight we have the chance to have Philippe Morel with us, who will be speaking about his researches and project. I'm only giving an introductory part of a few minutes just to say what is Design by Data. So Design by Data is an advanced master in computational design launching in September in Paris. And we are working a lot to launch this program. It's the kind of first time in France launching this kind of training, and it's an advanced master for architect, designer, and engineers who want to explore digital fabrication, computational design, robotics, and in general technology, building, construction, architecture, and design. Philippe Morel is the head of scientific committee of the master. I am Francesco Cingolani, the director, and I want just to tell something about Philippe in order to introduce him. So Philippe Morel is an architect and theorist. He's co-founder of AZCT Architecture, Design and Research, and more recently he founded the large-scale 3D printing corporation called X3. I think he's going to speak principally about this startup, and he's currently an associate professor at ENSA Paris-Malaquais in Paris, where he co-founded the Digital Knowledge Department, which is one of the most prestigious department in architecture school in France about computational design. So just to explain you how the session works, you have a chat on the right of the video that you can use to make questions, to interact between yourself. Philippe is going to speak for about 15 minutes or 20 minutes, and then if we want, you can have you can make a question, ask question, and discuss. So Philippe, it's up to you. Thank you very much for being with us.
Do you hear me now?
Yes, we can hear you, Philippe.
Do you see me as well?
Yes. It's perfect. You can go.
You all see me?
Yeah.
Okay. So, hello. Thank you, Francesco, for this short introduction. So you're right. I'm really happy to let's say, to be the head of the scientific committee of the master, which is now being launched at the École des Ponts. It's really a pleasure, and I hope it will be a great success. Actually, everybody is still working really hard on the program to make it as accurate and professional and scientific as possible. But I'm really confident in the fact that it will lead to amazingly good results. So now I will share my screen if it's okay. So if I'm right, you should see an image now. And actually, I will very quickly speak about additive manufacturing. As Francesco explained, I recently co-founded with some of my most brilliant students and friends and partner and investors as well. A small startup company which is called X3, which is entirely dedicated to large-scale additive manufacturing techniques. So basically, I will be super short because the idea is, in any case, to have a discussion about the real challenge. So here's an image of a stair, which was produced using topological optimization methods and software, actually, which was produced by Romain Duballet, a young engineer who was an intern last week at my office with Felix, actually, which is called Easy City, as Francesco mentioned already. And Romain is also a shareholder.
Actually, there is a little problem. You can just if you
Sorry.
The first screen doesn't work apparently.
Sorry, just a small technical issue.
If you can come back to yeah, that is your addiction.
Okay, do you see this screen?
Now,
because it seems that actually the one before didn't work, and does that one work?
It's okay now, Philippe. It's okay.
It's better?
Yeah, we can see the picture of the stairs.
So actually, so this is a stair produced by topological optimization software, actually, by Romain Duballet, who is an engineer who graduated from the École des Ponts. He's also a shareholder and a partner in X3, and is now...
I'm sorry, but just the problem is you can't use full screen. You
okay.
Just have to, yeah.
So I have to stay...
Yeah, you have to...
I can't use the full screen. Yeah. Don't worry. Okay, it's fine, no problem. So, and actually this stair produced by Romain, who is also part of X3, actually, is on the engineering side, and is also, by the way, a PhD candidate now at the École des Ponts. So, as you can see, it creates quite complex shapes. Here are a couple of images of mechanical analysis, actually, of this element. But the problem you have is first that the geometry is very dirty, and here I would say, I would refer to my friend Peter Macapia, who wrote a very beautiful essay entitled Dirty Geometry, who was published a couple of years ago. I think it's a very amazing essay in architectural theory. Here, so by the way, you first have to clean up the geometry. The more automated it is, the better it is, because it takes a long time, and it's a very, very boring job to do all of this by hand, obviously. And here is another approach of topological optimization, which is not done by a software. I mean a commercial software, but by a fully programmed algorithm, also programmed by Romain Duballet. He wrote the entire mechanical analysis library, but also obviously the genetic algorithm itself. The whole thing was written in Mathematica. So I will show you, by the way, a small piece of that was made by our company. Here is a project we made in Japan. It was a competition, and we were shortlisted for this competition last year. It was in Osaka, a very nice site, and we proposed a gigantically long building, some sort of a mega structure, which was more than 1 kilometer long. It was 1.2 kilometers. It was a super long building, completely made of a space frame, or let's say space truss, or 3D lattices element. We believe that, in fact, this is quite interesting. I mean, but it really creates new problems in architecture. If we want to do that in steel, it's not that difficult. We have the technique now to do this in steel. But if you want to do this in a continuous way, I mean, the way you would do it if you do small scale 3D printing, small-scale additive manufacturing, then it becomes a crazy challenge. So I really believe that the real challenge at the moment in architecture is to make the intrinsic geometrical and topological complexity associated with, I mean, usually topological optimizations buildable. It's a fact that 3D printing has the potential to revolutionize the way we make almost everything. I mean, this was even said by President Obama last year, I mean, 2 years ago. And we go from printing, I mean, from assembling to printing, etc., etc. But at the small scale, it's fine, actually. These are works done by my office, in our office with Felix. And we also move from homogeneous and simple structures and components to heterogeneous and smart design. This is a work which was done by Min-Soo Kim, a student of mine when I was leading a research studio at the UCL Bartlett with Thibaut Schwartz, actually, 2 years ago. These also are old projects from my office. But let's move a bit fast about that. But it's just to give you an idea of where this interest in three-dimensional lattice comes from. In fact, it does not come from an interest in space truss or in space frame. On the contrary, it comes from a long-standing interest in voxelized geometry. As you can see on these images, the principle is quite simple, in fact. We were thinking about a way to use voxels as individual cells and to create connectivity rules in order to create cavities inside, inside these cells, in fact, to create hollow cells in order to pour concrete, self-placing concrete in those cells. And I don't know if you see my mouse, probably not, moving here.
Yes, we can see it, Philippe.
But if you look at the top here, you see you clearly see actually a small piece of concrete, which is really three-dimensional, which in fact is the result of a concrete which was poured. So obviously it's a fiber reinforced concrete, which was poured, and thanks to the help of Lafarge-Holcim, actually, the famous cement manufacturer, which was poured in, let's say, in the, oops, sorry, which was poured in these cells. So it's not that beautiful, but I mean, conceptually speaking, the interest we have now, and I personally have in a three-dimensional lattice, does not come from the classical three-dimensional lattices. It really comes from an interest in voxelized geometry. I mean, defining rules, defining connectivity rules between voxels. And if you have pipes which are continuous between different voxels, actually, then you can pour some concrete in, and you can obtain this really amazing, let's say, three-dimensional concrete component. You can see here when you have something more complex, and at that time we realized this with my former interns, Tristan Gobin and Thibaut Schwartz, at the office. I mean, with the help of other interns and very talented students. You see here a polystyrene block, which is a voxel. You see the way it's cut, actually. And you see, when you remove this block, you see the kind of geometry you can obtain. So, in fact, and I will go really fast with these images, but let's say there are two concepts which are, let's say, at the root of what we are doing at the moment, and also what I'm trying to do myself with the X3 company. But X3 is dedicated to the large-scale 3D printing market, and it's not only about my own, let's say, specific interest about this kind of geometry, but it answers more global demands coming from various clients. I mean, we produce many different kinds of products and geometries. So, but basically, you see here the concept of recursivity, which is absolutely crucial, actually. You see very old experiment with space frame here as well. This was done also with the help of Justin Dierenberger, who is associate professor at the CNAM and is a researcher also in the PIM laboratory at NSAM. And at that time, it's already 2 years old. This is a research we presented at Ankilab. We used the voxel jet technology in order to cast concrete in. You see that we obtain quite high quality results with the cement. We are very proud that this piece was presented at the Centre Pompidou. So it was, I mean, it was first presented at the FRAC in the framework of Ankilab, but also later at the Centre Pompidou, which made it available to a wider audience. And I'm really also to, let's say, a non-specialized audience, which I believe is super important, actually. So you see this kind of very light, I would say extra light concrete lattice. It's probably, by the way, the very first extra light concrete lattice. There is only, I mean, if you see the wall element, which is quite big, actually, it's about 1.85 meters in diagonal. It's 65 centimeters deep and approximately 1.20 meter high. There's only 34 liters of concrete in these structures, which makes it super light. Basically, it's about 120 kilos. And as you can see, you can obtain extremely beautiful shapes and profiles with this. So what we are trying to do now with the new company we are creating is to develop this kind of work one step further. So I pass on alternative ways of doing this kind of lattices. This was also done at UCL Bantet by some of our students with Thibault, actually. And this was done last year by Clément Gosselin, who graduated with me. I was his director of studies. I mean, his main supervisor. The second supervisor was Jean-Aimé Chou, who is also an architect and engineer, actually working at Paris-Malaquais, at the École Nationale Supérieure d'Architecture Paris-Malaquais. And this, let's say, was at some point one of the bases of our decision to move, because this was an academic project, and Clément is also a very talented young graduate. He was then a student, obviously. Now he's a graduate. He's a young graduate, and we told ourselves, I mean, yeah, this has a lot of potential. Why not trying to move this to the next step and to create a company which would be entirely dedicated to large-scale 3D printing, allowing us to do this kind of work, but also this kind of work that you can see here. For example, this kind of three-dimensional lattice in concrete, actually. So we created the company X3. You can have some information about it just by going on the website, which is simply www.x3.com, actually. We are doing consulting, manufacturing, and technologies. So we are well equipped with robots, with various softwares, allowing us to do optimization of structure. Philippe Morel and Romain Duballet were both engineers and, by the way, very talented engineers are in charge of this part of the office, let's say the consulting part of the office. It led us to conceive this kind of structure in collaboration with some of our industrial partners, actually, and we really want to build this very soon. So you see the kind of geometries you get. You obviously see that it's quite tricky. So it's a good test for us because at the moment we are really trying to develop our system in order to make all of this, let's say, buildable. And again, I would say doing 3D printing at a small scale is not that much of a challenge anymore. I mean, this is what we believe. But making it well at large scale is really, really challenging. So we do molds in clay. You see a piece of mold here in clay. You see a more advanced and more complex one. So we master these techniques really well. Now we can answer more or less any kind of, let's say, requirement coming from third parties, I mean architects, engineering offices, or construction companies. As you can see, we can build this kind of lattice. This is exactly the result of the casting of concrete in this mold. In fact, it's not exactly this mold; it's the same. It's his brother. But you see the kind of shape and the kind of geometries we can obtain is I believe, very, very interesting. So this is, by the way, a small piece of the three-dimensional structure you have seen at the beginning of this small online lecture. It's cut at more or less 1 meter high, and the full structure was supposed, in fact, to be, if I remember well, something like 2.50 meters or something like that. But you see how let's say elegant and beautiful you can I mean the result can be. So yeah, that's all I would say for today. I would thank all of our partners, ABB, Lafarge Sim, Dassault, Altair, and all of our, and of course all of our academic partners who really helped us to do that. Maybe you can have a video. I can show you a small video, but in fact it's also on the website. And do you see the video?
No, I think the video is not working.
Maybe the video is working with Google Hangouts.
I think the best would be to share the link. What do you think? We can share the link.
I think you should see it. So let me try again.
You can hear the music.
If sorry, you should see it, no?
Now see your folder.
It's okay, no problem. if you go on the, maybe you can share the link.
Yeah, I will look for the link and I will share
So
with
if
the
you go
others.
on the www.x3.com, so it's xtreee.com, you will see the video I was willing to show you.
Philippe, I have.
So maybe you want to see me again?
Yes, Philippe,
See me now?
I have one question
Yes?
from Aldo. Aldo, that you know, is asking if we can visit your company during the advanced master. I think the answer is yes, but maybe you can tell us a little bit more about where are you going to be, because I know you are moving from one office to another, and also where are your machines based? I don't know.
So yeah. Actually, X3 will be a partner of the master. So obviously, we will make our facilities available to the students, and in fact, they are students, but at the same time, they are, for most of them, they will be already graduate architects or engineers, if I'm right. So we really want to challenge the whole construction industry and methods by developing this large-scale 3D printing company. So yes, this will be available for the master. At the moment, we are based in the south of Paris, approximately 50 kilometers at the south of Paris. We have a small industrial warehouse, fully equipped with everything we need to produce, I mean, building components. But we might definitely move in a new place. So I can't, I can't tell you where we
Okay,
will be exactly
I
when the
understand.
master will really start, but we might be in a larger place. In any case, the office part is also moving, and we will be in the cargo, which is a building which is just opening now. Um, we are part of the incubation program of the Impulse Partner startup uh, incubators, actually. So
Actually,
Impulse Partner.
I think Philippe is one of the largest incubator opening in France or something like that, right?
Yes. Yeah, and we are really happy to join this incubator, and we will definitely have a very beautiful office space with enough space to show some of our realization. I mean, some of our physical prototypes.
Mm-hmm. Philippe, I also have one more personal and at the same time it's a very general question. I'm curious about you. I know you have a very long career of research and work. I would like you to say something about the why do you think it's interesting for you to be part of
Oh,
a program like the Advanced Master Design by. So why do you think this kind of training is important? You already told to me, but I would like you to share with the others.
no, I mean, first, it's definitely an honor to be the head of a committee of a new master which is launched at the École des Ponts. Actually, I have a great respect for such a beautiful school and institution with the oldest engineering school in the world. Um, so in fact, it's both an honor and a pleasure because I really believe that the future of uh, architecture and construction and engineering will go, let's say, through new kinds of collaborations and new between architects and engineers, but also other people, programmers, software engineers, etc. But in fact, it's I would say it's probably one of the best places to launch such an educational program. I mean, it's a specialized master, and I'm absolutely sure that it's one of the it's a right place to do it. Let's say.
Thank you very much, Philippe. I think we don't have so much time left, but I have one question more from Federico from Argentina.
Yes.
Actually, this is a very interesting question because I always have one of my students asking this kind of question. So I'm reading it for you. The process you showed puts the accent on the optimization of geometry.
Sorry, the process.
Sorry.
What? Can you repeat
the process? Yeah.
I see. I can read it.
Yeah, you can read it.
So the process you showed puts the accent on the optimization of geometries. Which sort of decision you take as a designer in this sort of workflow? Yeah, this is a great issue actually. Let's say, as an architect, you can never completely expel some sort of subjectivity. I mean, you cannot completely avoid to put your own subjectivity in something. But at some point, we try to reduce the design decision, or at least personally, I try to reduce the design decision as much as possible because I'm much more interested in the invention of concepts. I believe, and this is probably also the path which is shown to us by the progress in various fields like artificial intelligence, for example, that we are going more and more towards a world in which the ultimate creation or creativity or invention will be conceptual. I mean, artificial intelligence has proven that many things are done by a machine in a much more satisfying way than what could be done by a human person. But what about the concept, for example? I mean, I wrote about that quite a long time ago when I wrote about the disappearance of the work, of the labor, and I wrote that the ultimate labor of the future would be conceptual. And at some point, when you are an architect, but it's also true when you are an artist, you have two parts in your work. I mean, one part is let's say conceptual, and one part is more or less practical. Much before the invention of conceptual art, artists were creating concept, obviously. And in fact, much before the invention of artists who don't do anything with their hand, this kind of art of let's say workshop collective labor existed as well. I mean, Rubens didn't paint all of his paintings. So what I mean is that whatever you do, you have a part of your work which is conceptual, and you have a part of your work which is technical. But with the advance of new softwares, artificial intelligence-based techniques, etc., the part which is really technical at some point is reduced to pure computation. And let's say the computer are much better than us to do computation. I mean, this is, by the way, why they are called computers. So if your work ultimately as a designer is about inventing concept and making computation, then it becomes more or less obvious that on a long term, the computational part will not be done by yourself. You will just create a concept. So what I mean is that what is the concept in this case? I mean, if you work with optimization software, you take some design decision, but it does not tell you much more. I mean, it does not tell you very much about the end result. I mean, how should I explain that? Because it's a bit of a tricky conceptual and philosophical question in a sense. But what I mean is that the whole issue is not about design decision. It's about the quality or the nature of the design decision. In some case, you can take a design decision which will be super classical, conceptually speaking, or even it can be extremely conservative and boring and etc. etc. And in some other cases, you will take conscious design decision, but this design decision won't be conservative at all. So I don't know how to explain that, but for me, I mean, personally, I always try to reduce the design decision to the minimum, but still, I don't believe that the problem at the very end is about design decision or no design decision. It's about the nature of the design decision you are taking. And when you use optimization software, most of the nature of the design decision, in fact, are, let's say, yeah, I don't know. It's difficult to say. Ultimately, I would say they are maybe probably based on aesthetics, because we are architects or artists and we are not just engineers. You know, I mean, Walter Gropius was saying that architecture starts where engineering stops. So
Okay.
because we are architects, maybe the nature of the design decision we take are intrinsically non, let's say, not based on purely engineering-related aspects, I would say.
Philippe, thank you very much for your answer, but we really need to close, even if, well, it's a very big and very complicated question. If you can turn off your micro, I think it's thanks.
Yeah, no problem. So thanks a lot to all of you, and I give you back your
Okay, because thank you very much, Philippe, for being with us. Just to close the
thank you. Bye-bye.
session, I wanted just to mention we have two more interesting questions about engineers and architect collaboration, but I think you answered in part to the question already. And we don't have more time to answer the question of Jean-Baptiste, but anyway, you can keep in touch with us via the blog designbydata.org. Applications for the master are still open, so if you have any question, just write us and we'll be happy to answer. Thank you very much, Philippe, again. Thank you very much, Domenico, for the technical assistance. Bye bye. Thank you very much, guys, for being with us.